So when we already downloaded all our digital elevation model for our study area from the Earth data website, we need to open a blank ArcMap document without any name because it's temporarily and we don't need it in the future. We just need to calculate factors that we need for LS factor. So let's go back to our theory, and this is the equation for LS factor. So we need flow accumulation multiplied cell size, this number, and sinus of the slope. So we need flow accumulation, cell size, and sinus of the slope. So cell size will be 30 to 30 because we will work with digital elevation model, and it's better to work with conventional 30 to 30 cell size. And sinus of the slope, so we will calculate slope from the digital elevation model, and we need also to calculate flow accumulation, and this is the most hardest part, because in order to calculate flow accumulation we need flow direction, and before that we need to apply fill operation to calculate to make the flow direction map. So we have multiple images, and we need to process several steps, and in order to facilitate our work we will use model builder. So let's open it, and let's just drag our all raster images to our model builder, and we need first of all to apply fill operation. Let's find it. So it's in spatial analysis tools, hydrology, and this is fill operation. Let's just drag it. So at first let's try to understand what does it mean. Fill sinks a surface raster to remove small imperfections in the data. So when you download digital elevation model, there are always small imperfections in the image. For instance, the difference between neighboring cells can be 100, 300 meters or 200%. So in real life it is hard to find such kind of areas. Therefore, we can assume that these are the mistakes. So fill operation cuts down some imperfections, discrepancies between neighboring cells, and smoothes the surface. So let's drag it, fill operation, to our model builder, and we need to replicate it. Ctrl C, Ctrl V, Ctrl C, Ctrl. So we need to repeat the step 8 times because we have 8 images. In my case, we have 8 raster images. So let's connect it, and now, so this is my first digital elevation model. So initially our output surface raster will be in default GDB, but I ask you not to save it in default GDB because in TIFF format, and when you try to save it in default GDB there is always a mistake because default GDB do not save TIFF format. So I created a folder, separate folder in my desktop, RUSLE, and I will save it here. So fill 1 TIFF. Let's save it.
Hey guys, if you like the video, please consider supporting the channel by purchasing online courses via my Udemy's profile, GIS Lab. Here you can find multiple courses regarding GIS remote sensing. The link to the profile is below.
So please create your own separate folder and save it in this folder, not in GDB, default GDB, because you cannot save a TIFF file in this database. So the fourth image. So I finished all my connecting input data with my fill operation and output data saved in RUSLE folder. And the next step will be to calculate flow direction. So we need to find now flow direction. So it's also in hydrology. This is a flow direction. So what does it do? creates a raster of flow direction from each cell to its downslope neighbor or neighbors using D8 multiple flow direction or D infinity methods. So let's drag it to our model builder, and we need also to calculate to repeat the same steps for the rest of the image. So now let's connect our output field. So we connect not with this digital elevation model, but with our field outputs, because that's why we created field. We apply field because it's impossible to calculate flow direction without applying field. So again, try to save flow direction. So I need try to save in separate folder, not in default GDB. So the flow direction type is D8, output drop raster is optional, so we don't need it. Flow direction D8, output name and field. So I just click OK, and let's repeat this same steps for the rest of the images. So I finished to connect my flow direction with my field output, flow direction tools, and this is my flow direction outputs. And the next step is to mosaic all my images into one, to merge them. So in order to do this, I will use data management tools. This is the raster and raster dataset. So this tool is mosaic to new raster. So I need to merge my field direction outputs. So this one is what I need. So field direction 1, 2, 3, and the rest. Oh, 8 images. 6, 7, 8. So output location. Again, I will use my here is this folder, my folder that I created, and here I will say mosaic flow direction.tif. So always try to save with extension, because it's mentioned here, raster dataset name with extension. So spatial reference system is actually initial intrinsic, it's so far VGS 84. So I will not change it in the future. When we will apply flow accumulation and extract study area, we will reproject it into UTM format. So pixel type 8-bit unsigned, it's optional, it's okay. Flow direction is always 8-bit unsigned. So a number of bands 1. So mosaic operator last, mosaic color mode first. So it's okay. So it's connected all my flow direction image. So it's my output. By the way, you should try to save your model, because if there is a mistake, flow direction, you can always change it, some errors, and fix it. So I saved. Let's first validate. It's okay so far, and let's start running our model. So it's a long process because it's processing 8 images. So at first it should apply fill operation for all 8 images, and afterwards it should apply flow direction operation for each 8 images, and afterwards it should merge it into one image, mosaic raster dataset. So I will pause the video here before it will finish. So now it's executing mosaic to new raster. So it's merging all flow direction output image into one. So it's completed successfully. So when your model is successfully run, so you should see this completed and no errors in this space. So let's close it, and let's close my model builder, and let's add our flow direction mosaic, this one in TIFF format. So it looks like this. See, I will close this raster image. It should look like this. So it's from 1 to 128. So you can just take a quick look for the flow direction tool. So each number represents a certain each value represents a certain direction of flow to which pixel the water coming from the top will gravitate to. So this is the end of this video. So we calculated flow direction for the whole study area, and the next step will be to calculate flow accumulation. So I will pause the video here.